right, chain rule day 2. Chain rule day 2. We're going to start off with these trig functions that you should have memorized. So you should pause that up right now, and you should be filling those in. I'm going to go because you're supposed to pause. So these should be memorized. So just be, bam, flashcards if you need to, whatever. Tangent is, derivative of tangent is secant squared. Okay? Derivative of secant is secant tangent. Secant x, tangent x. Secant squared x. Don't forget that angle after the trig function. Okay? Now, alright. And now, these, first of all, they start with c. So all those derivatives are negative. So we should have that memorized. And then, as far as like, it's not completely like, oh, this totally thing you have to memorize because it's connected here. So tangent goes with secant, cotangent goes with cosecant. That's cosecant squared x. And secant is secant tangent, cosecant is cosecant cotangent. Okay, so there's kind of some parallel there that should make it easier to remember. This is just a little reminder for asymptotes or discontinuities or whatever. This is the difference of two squares also. We're so used to the difference of two squares always being perfect squares that when we see something like this, sometimes it throws us off a little bit. So if you could pause this and factor that, that would be great. And you're back. So that is x plus the cube root of 3 as square root, and x minus the square root of 3. So if you think about that, when you multiply that back together, you would get x squared minus 3, square root of 3. Okay, so let's move on. We're doing the chain rule here. We have inner and outer. So the inner function is 3x. The outer function is sine. So let me do that. So the outer function we do first, the derivative of sine is cosine, and then you write down the inside just like it was. Then you multiply by the derivative of the inside. So the derivative of the inside is 3. So I'm going to put that in front. I talked about that before. I don't want anyone to confuse that with the angle over here. Okay. I'm going to do a little rewrite here. So that's going to be x to the 1/2. Alright. So the outer function is tangent. So the derivative of tangent is secant squared. So we have secant squared x to the 1/2. Now we want to, that was the outside. Now we need to multiply by the derivative of the inside. So again, I'm going to move that forward. So that's going to be 1/2 x to the negative 1/2. Alright? So that is going to be secant squared. I'm going to go ahead and switch that back to a square root instead of x to the 1/2 power. And then down the denominator I have a 2. And then this, because it's a negative exponent, is going to drop down as well. So we have that. Alright? And the derivative of cosecant. So the derivative of cosecant is cosecant negative, it starts with C, negative cosecant cotangent, and whatever's in there, you just write that down the same. Then we're going to multiply that by the derivative of the inside, which is 2x plus 1. But again, I like to have that in front because I don't want any confusion with angles there. So I'm going to just move that negative over here, and I'm going to put 2x plus 1. Now I forgot to say pause, but you should be pausing on all of those because those are all from kind of day 1. Okay. Now, repeated use of the chain rule. So that's if you have multiple layers. I call this the Shrek question. So I've got f of g of h of x. So I don't know if you remember from Shrek, the first one, where he talks about Shrek being like an onion. Or Shrek says he's like an onion, and Donkey says, why? Because you stink and make people cry, or something like that. And Shrek says, no, because I have layers. I'm layered. Many layers to me. So that's what's happening here. We have multiple layers. And I'm going to have this on some tests, repeated use of the chain rule. So we're going to have to break it down layer by layer. So the outside layer here is sine. Okay, so the derivative of sine is cosine. So we're going to go cosine, and then we're going to write all that stuff. So 1 plus tangent of 2x. Okay, so there's layer 1. And I can even color code this if you want. So layer 2 is right here. So that's layer 2. So now I need to take the derivative of that. So the derivative of that, the derivative of 1 is 0, and the derivative of tangent is secant squared. So that's going to be secant squared 2x. Okay? So that was layer 2. And now we can go in and the inner layer is 2x. So if we take the derivative of that, that's going to be 2. Alright? So that, color-coded for you. Now if you're not using different colors, then you can underline. So this was 1, and then, well actually all of this was 1, and then that was 2, and then that was 3. If you want to show it in layers like that without colors. So that was layer 3. The inner layer, this was the outer layer, and this was the middle layer. Alright? Okay, so out here. So this might throw you off a little bit, but really what this is the cosine of 3x, could have used brackets out there, but squared. So rewriting that helps. That's going to be, so outer layer, that's going to be 2. So you're just going to bring the 2 down and then times the cosine of 3x and subtract 1 from the exponent. So that's layer 1. Layer 2 is the cosine. So I'm going to take the derivative of cosine, and that's going to be negative sine. So calculus is just one step at a time. Don't get intimidated. One step at a time. And finally, the innermost layer, the derivative of that's going to be 3. So if we put all that together, that's going to be negative 6 cosine 3x sine 3x. Now, that takes us back over here. Okay? There's a connection between these two things. Anytime you see sine times cosine, you can think about, hey, that's the double angle formula. So if we break that down, if you recall, so before that we could have sine of 2x. So the double angle formula we can find by using the sine sum formula. So if you recall, that's the sine of the first angle and the cosine of the second angle plus the sine of the first angle cosine of the second angle. But because the two angles are equal, we end up getting this. Okay? So why are we thinking about this? Because I see a sine times a cosine with the same angle. So now if I'm looking here and I want it, so that's kind of what I have right there. So if we look, to go backwards, we take half the angle to go this way, and just kidding, we double the angle. We double the angle. We take half of the coefficient. Okay? So if we want to do this and we want to break it down to sine, so we want sine, we're going to double the angle, so that's going to be 6x, and we're going to take half the coefficient, so that's going to be negative 3. Now, if you're sitting there and you're like, man, I don't really know what you're talking about, it's not that big of a deal. Like that's not going to be on the AP Calculus test, but for those of you going in math or engineering, maybe you're going to have to do some of those trig identities and manipulation with stuff like that. Not a huge big deal. Okay. Evaluate the derivative at the given point. So think about that for a second. Evaluate the derivative at this point. So there's a redundant piece of information in here. I hope that most of you see that right away. You say, well, you know what, we don't even need the y coordinate if I'm just evaluating that. So y prime, evaluate, so I need the derivative. Saying take the derivative. So the derivative of this is going to be negative 3, 2x plus 1, subtract 1 from the exponent, chain rule, times the derivative of the inside, which is 2. So that is going to be, if I multiply those together, that's going to be negative 6 over, now, I don't know how much you feel comfortable with right here, but I could write 2x plus 1 down here to the fourth, or I could plug 1 in right now. So 2 times 1 is 2, 2 plus 1 is 3, so I could have 3 to the negative fourth down here, but actually when I move it down it'll become positive. So 3 to the fourth. Okay, now I may want to think about that for a second. So instead of multiplying that out right now, I think I will switch that up and I'll take 3 times 3 cubed. So hopefully you can see why we did that. So this can reduce right here to a 2, and we're going to get negative 2 over 27. All right. Now, this might be a good place to pause the video and see if you can do something about this on your own. Okay, so welcome back, and when you pause this, I hope you rewrote that as x to the negative 1 plus sine x to the 1/2 power, and you cross that off because we don't need that either. Okay, so that's just a rewrite, heart, yay, love rewriting stuff, it helps us. So the derivative, y prime, so that's going to be negative x, subtract 1 from the exponent, that's going to be negative 2. Now bring the 1/2 down, and then that's going to be the sine of x to the negative 1/2 power times the derivative of the inside. So the derivative of the inside is cosine. Okay? And so it's just a step-by-step process. If you practice this, it just gets pretty routine. So that's what we're trying to do. Practice, make it routine, make it easy, do the steps. So we're going to plug that in now at the same time. So this is going to be negative 1 over, and I'm putting pi over 2 squared. So that's going to be pi squared over 4 plus cosine of pi over 2 over 2 times the square root of sine pi over 2. Okay? So here this is a complex fraction, so I'm going to multiply by the common denominator. I'm going to multiply by 4 on the top and the bottom because I'm multiplying by 1. So that's going to give me negative 4. The 4's here are going to cancel, and that's just going to give me pi squared. Now if you want to keep, change, flip, multiply by the reciprocal, whatever, that works also. That's fine. Now the cosine of pi over 2 is 90 degrees, that's straight up, and the x coordinate of that is 0. So the cosine of pi over 2 is 0. And the sine of pi over 2 is the y coordinate, that's 1. Now none of that matters because that's all 0. So, I was thinking about circling that over there, but there we go. Alright, I don't know if you can see that underneath that. Okay, so, moving on to the next page, you could pause and start working on that there. So hopefully, I don't remember what color I was using, but I'm going to go with purple this time. So hopefully you pause and you do something right here. Equation of the tangent line. Immediately, you should be like, oh yeah, I know what that means. That means I should have y plus 1 equals space x minus 4. Automatic, child's play, bam, nice. Okay. So, now, to find the equation of the tangent line, we need the slope of the tangent line. To get the slope of the tangent line, we need to take the derivative of the function. Now, could do a little rewrite on that, or you could just, maybe in your head, you know that that's going to be the 1/2 power. It's up to you. So if you need to rewrite it, write it down up there. But I'm going to go straight into the derivative here. So it was to the 1/2 power. So that's going to be negative 1/2. Then I had x squared minus 4x plus 1. And then I'm going to subtract 1 from that. So that's going to be negative 1/2 power. And then times the derivative of the inside. So this is going to be 2x minus 4. Okay? So, that looks all right. So, there's a lot going on here. I don't want to combine too many steps at the same time. I do want to combine some steps at the same time, but I'm just trying to decide how many to do. So I can divide this by 2. That would be 2 times x minus 2. Factor 2 out. And then that 2 cancels out with this 2 over here. So now, if you think about your numerator, we have negative 1 times 4 minus 2. So that's going to be negative 2. This is all going to drop to the denominator. And if I plug 4 in there, that's going to be 16 minus 16 plus 1. So that's going to be negative 2 over the square root of 1, which is 1. So that's going to be negative 2. All right. You can pause that, obviously, or go back, rewind a little bit. Rewind. All right. So immediately, again, this is under that equation of the tangent line. So I should have y minus something equals the slope x minus pi. All right? So one of the things that I would do right now is I would go find that the y-coordinate. So we have the x-coordinate. We need the y-coordinate. We find the y-coordinate by plugging x in there. So that's going to be 2 times the tangent of pi plus the cosine of 2 pi squared. And you can't see that. I don't know why it curves up like that either, but okay. So the tangent of pi is 0. And the cosine of 2 pi is 1, so 1 squared is 1. So 0 plus 1 is 1. So the actual coordinates of this point are pi 1. So that's going to be y minus 1. And I could have boxed that whole thing off to begin with right there. Bam. All right. So we have done that many times already. So that should be, you should be getting used to that. Point slope form, equation of a tangent line, right there. So now all we're missing is the slope. For the slope, we're going to take the derivative. So the derivative of, so 2 is just a constant, so this is there. Derivative of tangent is secant squared. So secant squared plus. Okay, so now I have a triple layer chain rule here, so I don't want to lose track of this. So this whole thing is being squared. So don't let that confuse you. If you need to rewrite that, I did that in the other example. So we're going to bring the 2 down, and then we'll just have cosine of 2x. So that was squared. We bring that down, subtract 1. Now it's cosine to the first power. Now we're going to take the derivative of cosine. So the derivative of cosine is sine. It's going to be the sine of 2x. And then finally, that inner layer is 2x. Derivative of that's 2. Practice that. It's not that bad. Once you have it, not a big deal. Okay, so this is going to be 2 over, secant is 1 over cosine. So this is going to be cosine of pi, and that's going to be squared, plus 2 times the cosine of 2 pi, cosine of 2 pi. And I could have brought this up in front, I guess. That's a little bit awkward. Probably would be good to simplify some stuff. So that negative, that's going to be negative 4. cosine 2 pi, and then sine of 2 pi. Alright, so cosine of pi is negative 1. So that's going to be 2 over negative 1 squared. And then the cosine of 2 pi, that's positive 1, and the sine of 2 pi is 0. And I can go over that sometime if you need help on that, the unit circle and how we get those numbers. So this is all gone. That's going to be 2. So there you go. Now, we've had questions like this before. I told you this is important. They ask the question in this format a lot. So what they do is they give you values of derivatives and functions, and then they give you functions. So what this does is this stops you from using photomath. I'm pretty sure, unless if somebody has a way to do that, you let me know. I don't think photomath is going to do anything for you right here because there's no actual functions. So here, when you do this, take the derivative of this symbolically. So the derivative of this is going to be 3g of x squared times the derivative of the inside, which is going to be g prime of x. So write it down just like I am. Now we're going to plug in 2. So inside here is g of 2. g of 2 is negative 3. So I'm going to have negative 3 squared times g prime of 2, which is negative 6. So I'm just plugging in things to where they go. So that's going to be 9 times 18. Wait. Well, yeah. Negative. 9 times 18. I think that works fine. So this is 9. This is negative 18. So 18 times 9. That's going to be 72, 162. There's other ways you could do that, but I think that's good enough. Okay. Now we're going to do f prime of x equals, that doesn't really come into play, it's just kind of whatever. So here, the derivative of the outsides, that's going to be h prime, or g prime of h of x, times, that's the derivative of the outside, and the inside stays the same. Now we have to multiply by the derivative of the inside. So that would be that. So we have g prime, h of, this is all of 2, h of 2 is right there, that's 3. So that's 3, and h prime of 2 is negative 2. But we still have g prime of 3, so I need to go back up here. G prime of 3 is down here, that's 4. So that's going to be 4 times negative 2. That's going to be negative 8. Okay? And moving along, now we have, so this is the product rule. There's just a little review. Make sure you know what's going on here. So the derivative of the first thing times the second thing plus the first thing. Now I'm going kind of fast here, but you're supposed to be pausing. Like if you're just copying me write this stuff down, that's not practice. Like yeah, you're getting the notebook points, but like that's not the purpose of this. The purpose of this is your practice right here. This is some of the main practice. So anyway, h prime of x. So g prime of 2 is negative 6. h of 2 is 3. G of 2 is negative 3. And h prime of 2, I don't know if these are all of 2. h prime of 2 is negative 2. So that's going to be negative 18, and that's going to be plus 6, and that's minus 12. All right? Okay. Moving along, this is the quotient rule. So that's going to be low d high minus high d low over low squared. Okay? And you can put 2's where all those x's are as well if you wanted to, because that's what's happening. So now back up here, h of 2 is 3. G prime of 2 is negative 6 minus g of 2 is negative 3, h prime of 2 is negative 2, h of 2 is 3. Now, personally, I can see that all of those can be divided by 3 right now, so I think that would be probably a good idea. So I'm going to divide that by 3, I'm going to divide that by 3, and I'm going to divide this by 3. Don't lose track of that negative, though. Okay, so now I have negative 6, and I have 3 negatives, which is going to remain negative. And then I just have 3 down here. So that's negative 8/3. All right? And next one. So we had this the other day. Oh, actually, it's a chain rule, too. So they're kicking it up a notch here. As Emerald, I think his name is, that chef who said, let's kick it up a notch. So they're kicking it up a notch here. So you know these high powers of trig, or high derivatives of trig functions are like powers of I, sort of. So if we take the derivative of this, derivative of cosine is negative sine. So it would be negative sine, but then it would be times the inside, which would be times 2. So it would be negative 2 times the sine of 2x, right? The derivative of cosine is negative sine of 2x, then times the derivative of the inside would be times 2. Now, for the next one, the second derivative, that's going to be, the derivative of sine is cosine, cosine of 2x, times the derivative of the inside, which is times 2. So that would be times another 2. Now, instead of writing 4, I'm going to put 2 squared. Okay, so sometimes when we're trying to discover a pattern, it's better to leave things not simplified all the way because we can see a pattern in what's left. So again, we're going to go again, the third derivative. So the derivative of cosine is negative sine. So that's going to be, negative is going to make that positive. And then we're going to multiply by the derivative of the inside, which is times another 2. So that's going to be 2 cubed. So hopefully you see a pattern there, that whatever derivative we are on, that matches the power, the exponent of our coefficient. So now the trick from last time, if you remember, or the powers of I, is to take that number and divide it by 4, because this pattern repeats after 4. So if I take the derivative of this again, the derivative of sine is cosine, and I would be back. So that's going to be, 7's too much, 6, 24, 3. Remainder 3. That's the important number. The remainder tells us which derivative we're trying to get. So this is the same format as the third derivative, except the exponent is going to be different. The exponent is going to match the derivative, so it's going to be 2 to the 27th power, which is a pretty crazy big number, and then the sine of 2x. All right. And 4 more to go. Okay, this is a good one here. So, we have the quotient rule, and I can see in the denominator there's a function inside of another function, so I'm going to have to use a chain rule. So it's a quotient rule and a chain rule. So, low, and when I do this, I'm going to actually rewrite it, so that's going to help me in the process. So low, so there's low, d high, which is times 1, minus high. Now when I do d low, I can do it off here because I already rewrote it. So d low is 1/2 x squared minus 1, subtract 1 from the exponent, times the derivative of the inside. I have to use a chain rule. When I do d low has an inner and an outer function, so I have to take the derivative of the inside. All over low squared. Now that's actually pretty nice because when I square that, I get rid of the square root. We get rid of the square root. Okay? Now in this case, I think it's best to go ahead and write that out. So x squared times 1, that's just going to be there. Okay, these 2's are going to cancel out. And here we're going to have minus, and I have x times x, that's going to be x squared. And that's going to be over, this is a negative exponent, that's going to drop down. So that's going to be x squared minus 1 to the 1/2. And all of that is over x squared minus 1. I think we had something like this before, but maybe not. So this is a complex fraction. Again, that's why your honors geometry teacher tried to go over complex fractions with you when we did midpoints with fractions in them. Okay, so most of you. I want to clear the fraction, so I'm going to multiply by the common denominator. So if it bugs you, these are both over 1. If you want to see all three of them as fractions, rational expressions. So I'm going to multiply this by x squared minus 1 to the 1/2 and x squared minus 1 to the 1/2. So when I do that, when I multiply this times this, I just get x squared minus 1. Here, when I multiply, that cancels. So I'm going to get minus x squared. Here, these are the same base. So it looks a little odd. It's going to be x squared minus 1 to the 3/2. And those x squareds are going to cancel. Don't lose track of that negative. So that's going to be negative 1 over x squared minus 1 to the 3/2. All right. Okay, I'm just going to keep moving right along. Pause it to see if you can do this yourself. So it's going to be the 1/2 power. All right, so let's see. We're going to bring that down. 1/2 x over 4x minus 1 to the negative 1/2. All right. So that's the derivative of the outside. Okay. Bring the exponent down, subtract 1. Now I need to multiply by the derivative of the inside. Well, that's going to be the quotient rule. So that's going to be low d high, which is just times 1. You don't have to put times 1. I'm just keeping track of my derivatives. Low d high minus high d low. D low is just 4 over low squared. So that's going to be 4x minus 1 squared. All right. Now you got to be careful when you simplify the stuff up here because it's easy to lose track of stuff and not distribute and not. But this is going to be negative 4x and this is going to be positive 4x. So those are going to cancel out, and that's just going to leave us with negative 1 in the numerator. Now, let's see what's going on here. This is a negative 1/2. That's going to, so a negative exponent, what that does to a fraction is we take the reciprocal of it. So that's going to put a 4x minus 1 to the positive 1/2 in the numerator and an x to the positive 1/2 in the denominator. And then this 2 will come down here also. And then over here we have times negative 1 over 4x minus 1 squared. Okay, so this is going to reduce with that because they're the same base. So the numerator is going to be negative 1. This is going to be 2. I'm going to switch them back to square roots. 2 squared x. And then here, that's going to be 4x minus 1 to the 3/2. 3/2. So that's going to be the square root power over root cubed. Okay, pause that video. This is a Shrek question here. We already did this today, so it shouldn't be a big deal. Wrapping this up, zipping through these last 3. Shrek question, 3 layers, multi-layers. So if you want to, rewrite that. So that's going to be sine of 2x cubed. I think we have one 4-layer question at some point, but 4 layers. This is just 3 layers. So pause the video, do this yourself. So bring the 3 down, subtract 1, so it's going to be sine squared 2x. Now, don't let that throw you off. We did the power. Now the middle function is just sine. So the derivative of sine is cosine. So that's it. Okay? Now, the derivative of the inside is just going to be times 2. So if we put that together, that's going to be 6 sine squared 2x cosine 2x. Now you might be thinking to yourself, hey, what about that double angle thing you did? This is sine squared and that's cosine. that's not really going to help us that much. Yes, I could put a sine and a cosine together and then have another sine over here, but then you're going to have the sine of one angle times the sine of a different angle. That's not really that helpful. So we'll just leave that alone. All right. So this is just a pretty straightforward chain rule. So if we take the derivative of that, the derivative of cosine is sine. So it's going to be negative sine, actually. Remember, all the trig functions start with c have negative derivatives. So this would be negative, but I also realized I've got to do the chain rule, and I got to multiply by 3. So I'm going to do that. Now we need to plug that in. So that's going to be negative 3 sine. 3 times that is pi over 3. Okay, so here's what happens in my head for this. Pi over 3 is 60 degrees. So that goes up like that on the unit circle. You could draw the whole unit circle if you want. Okay, that's fine. I don't have room for it, but it's kind of like Spider-Man there, sort of. If I put another one over here, not really. All right. Anyway, sine is y coordinate. And so I think about the y coordinate here. The y coordinate here is big. Y is big. The big number is root 3 over 2. So that's how I piece that together. So that's going to be negative 3 root 2 over 2, negative 3 negative 3 root 3 over 2. The big number is root 3 over 2 times negative 3. Negative 3 times root 3 over 2. That would be that. Just like we were saying there a moment ago. Okay, last one. Let's wrap this up. Okay, so both these last two were on the 2008 AP exam. So that's an actual AP question. So find the derivative. So this is going to be the product rule and a chain rule. So if we do the derivative of the first thing, we get 1. Derivative of the first thing times the second thing, plus the first thing times the derivative of the second thing. So I'm just breaking it down one step at a time. So that's going to be x squared plus 2, subtract 1 off that. But it's a chain rule. From now on, always ask yourself, is there an inside function that I have to take the derivative of? So that's going to be times 2x. Derivative of 2 is 0. So that's gone. So that's it. Now when you look at that, I hope you notice that there is a factor, x squared plus 2, in both of these terms. There's two terms here. So if I factor that out, x squared plus 2, then I'm going to have an x squared plus 2 squared. And then here, one of those went out, and this times this, that's 6x. And then we have x minus 1, and we have x squared plus 2. Okay, so that looks pretty unpleasant because I should have factored out another one of those. So that was a rookie mistake. So I caught it though because I could see that there was one in both of those still. So I should have factored out that squared, and then this would be gone. Okay, so I'm trying to beat the bell here. I'm going to get that announcement that says I have to leave the building. So I'm trying to finish this up in time, which I should be okay, but usually one of the last ones out of the parking lot there. Okay, so now if we square this out, that's going to be x squared plus 2. This is going to be 6x squared minus 6x. So if we combine this stuff together, that's going to be 7x squared. Now it's a good idea, instead of trying to match it up, to actually write it down and then match it up. So I have this squared, and then in here I have 7x squared minus 6x plus 2. So now, and it's right there, but be super careful. Just make sure everything matches up, and that's the answer. And have a good night.